Let's understand Snell's law through this activity. For this one you need a glass slab, 4 iron nails, a pen and a scale, and a cardboard on which you can attach the iron nails. So you can start off by attaching 2 iron nails. You can see me attaching one right now, and you can do that. You can attach the 2 iron nails on one side of the glass slab like this. Alright, now we need to attach 2 more iron nails, and for that we will look at the glass slab through the face that is closer to us. So basically the face that you see in front of you, this face that I'm talking about. Here we see the images of the first 2 iron nails, right? And the new iron nails, they should be in a straight line to the images of these iron nails. So the 4 nails, that is the 2 images of the first 2 iron nails and the 2 new pins, they should be in a straight line, just like this. Alright, now we will remove these pins. First let's draw an outline of the glass slab. We have to be very careful as to not to shift the glass slab. So while drawing the outline, make sure you hold the glass slab at its position. Alright, now this is the outline that I drew. You can also join the edges, and I'm encircling the points where the pins were attached, the iron nails were attached, and I will join the first 2 like this. Alright, now I will join the other 2. Okay, now I will join the points where these 2 lines are cutting with the glass slab. So there you go. Okay, so this path that we see, this is the path that light took and then reached our eye. So I'm drawing the arrows to show that path of light. Now we can draw a couple of normals. Normal is a line which is perpendicular to a face, so it should be 90 degrees. So you see one normal at the top face, and I'm drawing one more normal over here. Alright, now this angle that you see, this is the angle that the incident ray is making with a normal, and this angle is called angle of incidence, denoted by small I. This angle is called angle of emergence because it is the emergent ray, that is the ray that is coming out of the glass slab, the angle that the emergent ray is making with the normal. And this angle that you see, this is the angle of refraction because this is the angle that the refracted ray is making with the normal. Now let's try and measure the angle of incidence and the angle of refraction. So angle of incidence is coming out to be somewhere around 24 degrees, and now let's measure the angle of refraction. So angle of refraction is coming out to be 15 degrees. Alright, now the Snell's law states that the sine of the angle of incidence divided by the sine of the angle of refraction, that equals the refractive index of the material through which the light is passing. In this case the light is passing through glass, so refractive index of glass. So that means the sine of angle of incidence I divided by the sine of angle of refraction R, and angle of incidence is 24, angle of refraction is 15. Sine of 24 is equal to 0.41 and sine of 15 is equal to 0.26. So we need to divide 0.41 by 0.26, and that comes out to be equal to 1.58, which is the refractive index of glass. So you can also carry out this activity even if you do not have the glass slab. You can use a bowl of water. Make sure the bowl is transparent so that you can attach the pins or iron nails, and go ahead, try this activity.